Guys, welcome back to a new video. So let me change the view. Yep. So today's question is min stack. So if you are new to this channel and haven't subscribed yet, please consider subscribing. I solved all these much of problems till now. You can find all these video solution of this problem over my channel. You can check out this like this shared slash Shubham Chhimpa, and then you can go to videos where you can find all these videos, or you can open the playlist where you can find this Neetcode 150 problems playlist. Yep, so let me quickly move to this problem, min stack problem. So it is marked as medium. It is a kind of a tricky problem, but it is a very easy problem. So let me just read the question. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time, that is O of 1. Implement this. Yep, we have given these function. We have to implement them. Your solution must be with time complexity. Yeah, okay. So the time complexity will be this O of 1 or constant time. So the input will be like -2, 0, -3. So this will be push, and then we have to get min, that will give -3 as the minimum till now. Then we will pop one element, that is -3, so the remaining element will be -2 and 0. Then it will get the top, so the top is 0, so yeah, it is 0 here. Then it will call get min. So get min is, so what is the minimum is -2, so that's why it is -2. Okay, so what we can do is, so we can have a stack. Let me quickly write the code. It's very simple, and the logic and approach is very simple. As I will write the code, I will explain you the logic. So we will have a stack. Let me write the stack, which will contains a element. So a stack can contain a single element, and it is pushed in like in this orders, like first order will be like -2, then 0 and -3. So there is no indexing here, like that of in vector or arrays. So yeah, we will store a pair of element in this stack. So let me name it as S. Yep. And what we will do is, when we push element, so the first element will be the input element. So the first element in this pair will be the input element, and the second element will have the minimum value till now. So initially, when we insert the first value, the first value will be the value will be the value, and the minimum will also be the value, because there is no current value till now. So the minimum is the current value, the first value. So if our s is empty, then as I told you, s dot push the value and the value. So this is the value and this is the minimum till now. So since this is the first element, so the minimum will be like is equal to the value. Otherwise, in other cases, when there is one single element present in one or more elements present in stack, so what we will do is, we will push, the first will be the input current value, and the second is the minimum till now. So how we'll calculate the minimum till now? So we will use this function minimum, which will give us the minimum of two values, which is the current value and value, minimum value till now we store as. So there will be at least one value if we go to this else condition. So we will get the top, and the top second is the minimum till now. Okay. So this is the minimum till now, and this is the current value. So whatever be the minimum of these two value will be the minimum of for the current pushing value. So the value which we are currently pushing into the stack at the top of the stack. So yeah, so this will store the minimum value like this. Okay, and one simple logic for pop is s dot pop, and for top, so for top we have to return the value at the top. So we will return s dot top dot first. So first is the value, actual value at that position or the top, and get minimum will return like this, s dot top. The minimum till now is we are storing in the second of the pair. So yep, so this will be the code. Let me just check quickly. Yeah, it's working for this case. Let me submit and check for other cases as well. Yeah, it's working for other cases as well. So let's quickly check the time complexity. So this is a stack, built-in stack. So pushing into a stack will takes of one. So here we are just pushing an element, not doing. We are not doing anything else here. So the time complexity of this function is of one. And popping out element from a stack is also of one operation. So yeah, this is also of one. And top, we are just seeking the top, which is also of one operation. Yeah, and get minimum also is seeking from the top. So yeah, this is also of one. So as required the condition, we have to implement all the functions is of when we have like implemented correctly. And also the space complexity will be the if we consider the elements as space complexity, so then it will be of n. If we are not considering them as a space, extra space, then it will be of one. So yeah, so this is the question about the question. If you like the video, please click on the like button. Let me check which one. Yep. And then let me just check this. Yeah, we have completed this. Tomorrow we are going to solve this evaluate reverse polish notation. So consider subscribing, and yeah, I will see you in the next video.